Hey everybody, Mr. Piercy here, and what I'm going to be demonstrating for you today is how the uh, relationship between an angle exterior to a circle that's formed by secant segments or tangent segments, how the exterior angle measure compares to the measure of the arcs that it intercepts. So for the demonstration, I'm going to use a compass, a protractor, and a couple of different colored pencils, so that way we uh, can differentiate some angles that we're going to be using. Now, the way that I'm going to do this is to begin by making a circle with my compass, something big enough that we can measure some things on it, but not anything that has to be crazy small either. It doesn't need to be real big, real small, but something just big enough that we can add some things on here and perform our investigation. Now what I'm going to do is I'm going to create a secant here and a secant here, just so that way it's nothing special, just however you wanted to make it. You could make it closer to the center, further away from the center. But we have a secant segment here, and I'm going to call this point P. I'll call the circle K, and H, I, L, and M. So we have some points that we can use as reference. Now, ultimately, we're looking to see what's the measurement of the angle out here, the angle P. That's the whole purpose of the video. What is the relationship of that with the arcs that it intercepts? So I want to know what is the measurement of angle P. So let's go ahead and take a second and measure what this guy here is. And I'm getting this to be right at about, it looks like it's real close. It's hard to tell, 39, 40 degrees. Oh, you can't really see it, can you? To me, that looks like right around 39 degrees. Wait, nope, I can't count. 34 degrees. So let's see, let's go ahead and call that here 34 degrees. Now, this exterior angle P intercepts two arcs on the circle. It intercepts arc IL and it intercepts arc HM. So we want to know, well, what are the measurements of those angles? So the way that we measure, or not the measurement of the angles, the measurement of the arcs, the way that we figure out what the measurement of those arcs are is by measuring what their central angles are, because the measurement of an arc and the measurement of its central angle are the same. Now I'm going to have to extend this line out here a little bit, because the type of protractor that I have, it's just the angle is too small the way it is on the circle. I need to make it just a little bit bigger. And here I'm going to add this arc, or I'm sorry, this central angle. And I'm going to do the same thing here. I'm going to make this one just a little bit longer than it really needs to be properly, so that way I have it just big enough so that I can measure it. So let's find the measurements of these arcs. The measurement of arc HM. What does it equal? So using the protractor here, this one to me on mine looks right at about 109, no, 106 degrees. Oh, wrong way. Yeah, right at about 106 degrees. So I'm gonna say 106 for the measurement of that arc. And now I'm going to have to turn my paper around so I can measure this angle. And let's see, so Oh, I can't get my protractor lined up here. This one here looks right at about 38 degrees. Zoom in a little bit here so you can. 38 degrees. So I'm going to add that measurement here, and I'm going to say the measurement of arc IL is equal to 38 degrees. Now, when we do this kind of investigation in class, the measurements themselves can be a little tricky to get sometimes. Students always have, varying degrees of accuracy with their measurements. But once we have our angle measures, we start to say, well, how does the measurements of these two arcs compare to this? And this is where students really struggle because this one is not a very intuitive operation. Okay? This one isn't very, it's not going to just kind of jump out at you. But here, if we add these two together, so let's go ahead and get our calculator, because this is what kids start doing. When I insist on, well, there has to be some kind of relationship. What is it? Well, this is what a lot of kids do, especially because this is usually the second thing, the second investigation that we do. And so they want to try and do what they did in the first one. They say, well, let's add these two together and divide by 2 and say, oh, well, that's not 70, that's not 34. It didn't work out. And so they try a variety of things, but eventually they will say, well, let's say 106 minus the 38. And then if they divide that by 2, you say, oh, hey, that happens to be the same measurement of the angle as it was outside. So while it's not a very intuitive thing here where you're looking at these two and saying, oh, let's take the difference of them and then divide it by 2. We're not taking the average anymore, we're taking the difference. So the way that we'll say this is that the measurement of the exterior angle will be equal to half of the bigger arc, which would be the measurement of arc HM, minus the measurement of the smaller arc, which would be IL. And that is the connection between the measurement of an angle outside of a circle formed by secant segments. It would also work for tangent segments, and the arcs that it intercepts inside of a circle. But if you have any questions about anything you've seen, guys, please be sure to let me know what they are, and I'll be happy to help you with whatever.